link the other two halves of the lectures. So let's go to another semester, autumn 2019, and the manufacturing engineering. Oh, wait. That's autumn 2000. Yeah, autumn 2019. The Gray Center. I hope we will find some examples before, because I think one of the semester they removed everything. Okay, so we talk about the submission of the major project. Let's try to find. Actually, too many people got good marks there. Oh, I think that's the one we saw. It was autumn 2019, Stephen. Or autumn 2020. I show you.
I thought it was 20.
But this name seems to be familiar. Anyway, let's check this one. Okay. Okay, so cover page. Okay. So once again, we are going to have the table of contents. I will go slow on this one, so you will see the parts he made. First, introduction. Second, the gear pump, analysis of the components, the driver gear, the driven gear. Okay, so he didn't left anything. The mounting and flange, the seal, the pushing, the drive shaft, the suction and the pressure port, and the case seal. He talked about the direction of the driver gear, the port sizes, the lubrication, and the engineering diagrams. Actually, from 1.1 to 1.4, he took everything from this slide number 1 we had for the major project. The engineering diagrams, you already have engineering diagrams available on the UTS online. The material selection and justification, once again, these things are mentioned, but we're going to see what he done. So first, material requirements. Second, the material selections. And he's talked about the different types of the iron. So, of course, for the iron, we are going to use, for example, the graphite iron or the gray cast iron to make the body. The steel alloy and the mild steel is going to be for the shafts. For the aluminium is going to be for the thrust plates. Oh, the thrust plates can be made of copper, by the way. Teflon coated steel, this will be for the pushes, and the rubber, the manufacturing processes. Oh, by the way, you don't have to tell the process of manufacturing of the rubber here, okay, or the seals, because these are the off-shelf items. You don't have to mention how they were made. As a production engineer, you're only going to tell the workshop how to make the parts you are going to make in your factory, not the one you are going to import or you get it from the external supplier. So, yes, sorry.
How do you know which parts you buy off the shelf and which parts you don't?
I will go down and I'm going to tell you. Okay.
All right,
now,
cool.
for example, all the bolts are not going to make them, right? For the seals, you're not going to make them. You just purchase them. Okay. What else do we have? Yeah, bolts and all seals. Is all, yeah. Yep. It's all going to be off-shelf items. So the required equipment and the processes. Okay, now it's not going to be like that. Maybe it's going to be as a process, yes. But once again, I told you that, well, even if you go all around Australia or even China, you're not going to find the same factory making all these processes at the same time. Okay, so die casting. Why die casting? Actually, is going to be the main body is going to be by the sand casting, not going to be die casting. The thrust plate is going to be done by the die casting. Milling operation, lathe, CNC machining, tungsten carbide turning tools, the ceramic turning tools. Maybe just a list of all the process. Manufacturing of the gear pump, driver gear, the material wastage calculation. He should add calculation. Thrust plate, the main body, studded face, studded hole, double holes, 3 holes, the gear. Actually, this is very classical, but anyway, he got the good mark, so we have to accept that. Okay, alternative manufacturing process is going to be drilling and tapping. That's it. No, actually, for you
That would
guys,
be an alternative process.
yeah,
It's part of the process.
exactly. So when we talk about the manufacturing process, I will take another report. When we talk about the manufacturing processes and the alternative processes, for example, you can do the main body by the sand casting, but also you can do it by machining. So this will be alternative process. I can bring a block and start to remove the material and again to have the same shape of the body. That's alternative process, but not going to be drilling. That's alternative one. That's not alternative process. Also for the driver gear and driven gear, if I'm going to do the machining of the gear by using the milling operation, also I can do it by the hobbing operations. So not hobbing, sorry. Yeah, gear hoppers. So yeah, so this will be the alternative operation, but not drilling and the tapping. Critical tolerances. We talked about this one in the third part, which is going to be the faces and dimension of the dowel holes. The flow chart, which is actually, we talked about this one earlier. Calculations, the quality insurance and inspection, the estimation of the manufacturing cost. That's classical thing. Let's go through this one. Introduction. Everything we can see here is actually from the slides. This is very important to remember that if you in the lab, if you calculated the gray pump dimension, you will say is going to be the PUKS 50R. If you did the purple one, it's going to be 85R. The also of the components, the driven gear, the mounting and flange, the seal, the pushing, the suction pressure ports, the case seal. Actually, this will be nice if you're going to put some photos for this part as well. Direction of the driver gear. Okay, I'm just going through this one slowly so you can read it later when you watch the video. The port sizes. Doesn't have to be these details. The lubrications, the lubrication within the shaft. Yes, because actually it's running hydraulic, so it's going to lubricate itself. Engineering drawings. Well, I prefer that you put this one as an appendix and refer to it. Material selection. Okay, then he started to talk about different materials. Now, if I was in market, I prefer that when you write down material selection, you write down here, for example, the main body and the cup, and you talk about the different materials we're going to use. For manufacture them. Steel alloy, driving and driven gear is going to be use of the steel alloy, and does have some advantages and disadvantages. And the alternative materials can be the mild steel. The aluminium is going to be done for the thruster plate and the gear pump and actually, I can see that this guy copied and pasted something, but I don't know why he only have 21%, because I read these things earlier somewhere else. Teflon steel coating, rubber, manufacturing processes, and well, I didn't like this report so far. Because it's just putting a lot of content, but without describing about how we are going to use them, for example. Okay, so die casting is the flowchart. I like the flowchart once again because it can tell a lot in one page more than what 20 page can tell. The milling operation, the lathe, the CNC machine. Well, I don't know what's that. Anyway, I think turning tools, the ceramic turning tools. Okay, manufacturing of the gear pump. Okay. That's the example. While the actual dimensions will never go to the 80, the actual dimension was the maximum starting from 60, then you go until you do the finishing operation. You can put the tables as he done here. The material wastage calculation. Don't do that. Okay, just use the other process I told you about. We estimate what was the dimension of the original stock material to make the shaft. We know the density, then we can find, by this process, we can find the volume. But I don't know why he calculating the volume of the teeth. How is supposed to find the volume of the teeth? Okay. Volume of the wasted product is going to be difference. Yep. Well, I don't know how he did this calculation. Okay. And the thruster plate manufacturing is going to be done by the die casting. Now, once again, we can use alternative to the aluminum. We can use the copper to do the thruster plates. The main body is going to be done by the sand casting. Does he mention that? Okay. So, sorry?
In the second line, he talks about using a green cast sand.
No, I was reading actually yes comment. I asked the mass of the shaft gear was 1,556 grams, and the density of the steel is 7,800. Oh, I know, but where are we going to have the bathtub? If you did this way, this would be good, but I doubt that we did it that way and with the accuracy required. Yes, sorry, Stephen, you were talking about yes using ring cast molding. Spherical iron is going to be molten in there. You can see. Well, I like the way he using the references. Okay, easily broken apart using the vibration machine. Newly casted gears body now. Progress in the milling, the main body of the gear pumps gain directional chunks. Okay, so he start to talk about the started phase. I will leave this table in front of you. He talked about the operation, the accuracy, the tool we use, and the cutting speed for every operation. Our started phase, finishing on the started phase. Okay. For the stud holes, drill the holes, drill the stud holes, finish hole, tap hole. Okay. No, there's no such thing. There's no rough drilling and the finished drilling. The drilling is drilling. Drilling, and you need to do the tapping. For a double hole, you need to do the drilling. Well, it's going to be drilling, boring, and reaming. This will be the process for the double hole. Drilling, boring, and reaming. And then you're going to press fit the dowel inside. I don't understand this one. Okay, the thread holes. Oh, wait, what's that and what's that? Well, can someone tell me what difference between the stud hole and the dowel hole?
There isn't.
There isn't. Anyway, well, you can, if you know this person, please don't tell him I said something bad again in his report. Okay, thread holes, drill hole. Once again, just drill the hole, bore the hole to enlarge it, and then you need to do the tapping. That's it. I can see the things actually just keep repeating, right? Stud hole, dowel hole, thread hole. The gear push boring, yep, they're going to do the rub bore hole, rub bore hole for the push. We said actually one operation, one cutting tool can do the work. If you're going to use the custom cutting tool, multiple stages, finish the bore hole and finish the bore hole by the bushes. Okay, inlet and the outlet port, we're going to do the boring. Actually, it's going to be just the boring, then we need to do the threading. It's not going to be tab, this will be thread operation because the hole is quite big. It's not going to be done with a single cutting tool. It's going to be done by using the milling machine to create the thread, internal thread on the big holes. Anyway, they just passed this one without reading. I don't know why the thing is just keep repeating. Alternative manufacturing process, drilling and the tapping, critical tolerances we have, driver and drilling gear shafts. The gears itself actually also going to be critical points because we don't want to have the hanging of the gears if the dimensions or the surface is going to be too bad. And also the surface finishing of the face of the main body, it shouldn't be, it should have good accuracy. Otherwise, we're going to have leaking for the oil at the higher pressure. The bearing and the dowels flow chart is showing here until we're going to have the assembly process. The calculation we done earlier. Okay, and what else? The quality insurance and inspection. Okay, so once again, he mentioned that here, I think. But the first process we're going to do for the inspection is taking the main body, taking the cup, seal them, plug the two of the outlets and pressurize the third one and leave it at higher pressure for a while to check if the main body is going to be explode under the higher pressure or not. We pressurize it with water because water is clean and also have a good viscosity and is compressible fluid. Okay, the quality insurance inspection. After we finish the operation, of course, all the dimensions should be checked by using the CMM machine. Surface roughness should be done for all the combos for the shaft and the cavities. And also the last test we do for the pumps usually is going to be a simple depump, run it at the maximum RPM value and check the pressure. If it's going to give you the desired pressure, this will be that's when your product has passed the test. Okay, estimation of manufacturing cost. 3 hour die casting. Die casting is not going to take 48 hours. Okay, so he just counted. Anyway, equipment, die casting.
I think those pumps are about $1,250 on the market.
Yeah. Yeah, actually, I'm reading many things. Now, he didn't mention anything about the sand casting. He just kept repeating the die casting. We have the sand casting. Die casting machine never going to be $5,000 because we said that the mold is going to be too expensive. Anyway, So just an estimation. It seems that the people who do the marking actually just reading if he put the assignment criteria, he fulfilled the marking criteria. This is it. They gave him the mark against that. I'll try to check another report before we get back to the lecture because actually this report was negative to my mood. Okay, now let's take a look to another one. Okay. Okay. Oh, he put the abstract and table of contents, application operation, pressure port tolerances, components, body, gears, truss plates, gear pushing, suction and pressure ports, the materials for the body. For now, this one is even better because he described the material per part, and this is what we need for the readers. For example, if I don't understand what the pump is, when I'm going to see that, you will tell me what the body is going to be made of, what the gears are going to be made of, what thruster plate, what the pushing. And then he have the drawings, manufacturing processes, the gear body, the machine processes, the main body machining processes, the gears, the material wastage, thruster plate, final product inspection, calculation, manufacturing costs, and the references. Okay, some short introduction. The application and the operation of the pumps. Okay, the pressure ports. He had the photo for that. That's good. Okay, the tolerances to ensure that the gear pump will operate smoothly and without any hiccups. The most crucial components that need to have the high tolerances are going to be the gear shaft and its meshing faces, the pushing and the dowel positioning areas, and the wheels and the dowels. The gear shaft are to mesh accurately to ensure that the fluid flow can be as smooth as possible without compromising the durability and efficiency. The pushing and the dowel positioning are going to be very accurate. Let me tell you something that the dowel actually is not going to be very accurate because it's only going to guide you about the positioning of the two parts of the gears. And two parts of the body are going to be made accurately related to the misalignment and before the cause of the unnecessary wear. The components. Okay, now the body, the gears, and for each one, it's going to talk about the material, I think, thruster plate, the gear pushing, the suction and the pressure ports, the material for each part, and the pushing. Okay, if I was you, I will for this one I will talk about that as the main material, and then I will write down what will be the alternative material for each one. I can put it as 1 and 2. So this will be highlighting the marking criteria. The drawings, the same drawings actually, shared by everyone. The manufacturing processes. Yes, this one is actually doing the sand casting, which is good. Okay, manufacturing processes. And once again, I think that he showed that as a flow chart, which is good. So once again, yes, he's talking about the gear body, how it's made. And you can put the alternative process here as well. So once again, you can do it as a sand casting, but also you can do it by machining. Just get a block and remove the material. The advantage is that if you are going to have the, for example, a patch manufacturing, so you don't have to contracting the foundry to cast the main body for you. You can do it on your CNC machine, but you consider the embossing of the material. Okay, so this can be an alternative process. He did the tabling, which is good. everything we got from the session number 3. For the gears, now it's going to be a crime if you're going to say that the gears can be made by the casting. The gears, the shaft, never made by casting. Again, to take the rod and machine them. So the only alternative method we're going to have is we can do the cutting of the gears by the hooping, or we can do it simply by the milling machine. This will be alternative process to make the gears, not the shaft itself. What if the cast roughly? No, because the property is going to be different, yes. The properties of the metal, the hardness, the strength, and the other properties, the casted one is going to be too brittle. Well, when it starts to rotate, it is going to be breaking as a cucumber. So always try to avoid using the casted shaft. No, nobody using that. Okay, the material wastage calculation, and actually you can find the calculation here. This is a good one. Okay, and the machining process for the gears, the thrust plate. Okay, now these are the thrust plates. You can do it by the injection molding. Don't think about making them with the machining, because holding these parts is going to be quite difficult through the machining process. But the only alternative we can have for that is, once again, this one is made of aluminum. We can use one made of copper. The final product inspection, I will leave this one in front of you. The hardness test, the pressure testing to a simple part, and ensure that the teeth of the gear is going to be meshing probably without any issue that may cause the failure to occur. Testing each component to its failure points using the several different testing methods, assembling the gear pump and testing the pump till failure multiple times to establish the failure points to notify the customer to the limits of the pumps. Okay. Okay, and some calculation. Well, I like this report actually. It's much better quality than the previous one. Manufacturing cost, the times. I'll leave this one in front of you for a while. Okay, and manufacturing, prepare metal for the manufacturing metal using different processes, testing, and the final assembly. For the materials, for the equipment, for the labors. Okay, I like this one. Okay, so I think that's enough. Okay, so I'm going to stop the recording of this session, and we're going to go back to